wants us to have?
Yeah, this is what I would do. You would have two circuits. The same circuit you guys built. One would be where the person's going to sit. The other one is going to be a circuit that's with a sensor hanging out in the air.
So what other circuit could we build?
No, you're building the same circuit twice, essentially. And you can have one AD converter. The AD converter can sample the input of one circuit and then store it as a digital word. And then the one that's kind of hanging in the air, you can sample that one and hang it and generate a digital word. And then what you do is take the two numbers and subtract them from each other. If the difference is 0, that means that both sensors are at the same temperature. If the difference is non-zero, that means one is much warmer and the other one is much cooler.
So what if a different person touches the circuit? Isn't that going to change the temperature?
Well, what the assumption is, the one that's a reference sensor is going to be in a place where the person can't touch it.
Okay.
So, for example, you might have a sensor that's embedded in the desk in an area that the person can't put their hands on. So that's a reference sensor. Its temperature is constant. Its temperature is going to be based on the room temperature. Okay, and then the other one is going to be placed in a position where the person can make physical contact with it.
But he was saying that the room temperature is gonna change also.
Yeah, that's right. That's why I'm saying you got two circuits.
Okay.
One circuit is grabbing the room temperature. The other circuit is grabbing the temperature of the sensor that's making contact with the person.
Okay.
And what I'm saying is if you take these two sensors output and subtract them from each other, the difference should be 0 if there's nobody there. If somebody is there, then the difference is going to be non-zero.
So attaching one circuit to the AD converter and AD converter to what?
Well, no, what's going to happen is you have both circuits attached to the AD converter. If you look at the HC12, it actually has an analog multiplexer attached to the AD converter. And what that does, it allows you to select multiple inputs. So one input could be attached to the reference circuit. Another input could be attached to the sensor that the person's going to sit on.
Okay.
Okay, you see what I'm saying? And what you do is you sample this one, and then the circuit will process the information. You do the conversion, save that digital word in the register. Let's say it's in register A. And then the other one is sampled is in register B. And you subtract the two from each other. If the difference is 0, that means there's nobody there. If the difference is non-zero, that means there's somebody there.
Okay.
Okay? So basically, again, you just duplicating the circuit.
Okay.
You only need one ADD converter, but you're going to have two analog circuits.
And do you think that's complex enough? Because
yeah,
he was saying
the problem that he's talking about.
But he was saying that circuit we have is too basic. Because we need more than one element in there. Something else besides the thermistor.
Well, I mean, we can make the circuit more complex because one of the problems with your circuit is you're not really taking advantage of the gain of the circuit. So you can build it and make it more sensitive. For example, instead of building, see how this is built? You can take that output and go to another op amp and then go to the ADD converter. And then that'll amplify the difference, which means your circuit will be more sensitive to temperature differences.
So you're saying have two op amps instead of
right.
one?
One will be this circuit, which is the sensor structure. The next one will be an amplifier to increase the sensitivity of the circuit. And then that goes to your ADD converter.
Okay. Because he said multiple elements.
Yeah, I mean, when you build another amplifier, you're going to have some additional resistors and stuff.
Yeah.
And remember, you're going to have two of these circuits. So you're going to have two sensor structures, two amplifiers, and then all that's going to feed your ADD converter.
Okay. Well, I'm going to ask him just to make sure that's good enough.
Add more. You can also add some circuitry to minimize electronic noise. Like you have a low pass filter, a really low pass filter. Because I'm sure you guys have noticed on a lot of circuits where the signal's amplified, if you touch it, you hear like a hum. I'm sure you've never noticed that.
I have.
And you can actually have a filter that will filter that out before you process your signal. So if you wanted to, you can actually add a filter to this thing too.
Okay, and that's to our basics circuit that I showed you today.
Right.
Okay.
So again, because noise will be a problem unless you filter it out.
Okay. Okay.
So a low pass filter probably should work. What you want to do is pass signals with frequencies much lower than maybe 2 or 3 hertz, because the primary source of noise in most environments it's a 60 cycle hum that's coming from these signals, from like lights and everything else.
Okay.
And so what you want to do is you want to block out anything that's maybe higher than 10 hertz.
Okay. Okay.
Because this thing right here, believe me, is going to be super low frequency. So 10 hertz is fine.
Okay. All right. Thank
Okay.
you.
Mhm.